Good morning and welcome to Advent of Code in F# day 6. Before we dive into today's puzzle, I want to quickly pass by yesterday's puzzle again, because I got some feedback from several people. So if you remember, we were trying to find our seat on the plane, and we got these input strings, FB, LR, and we basically had to find our row and column number and then do some weird multiplication to get a seat ID. Well, it turned out this was a very roundabout way of converting a binary number to an integer. So with that information in hindsight, I decided to tackle the problem again, and it's a bit easier that way. Or no, it's not easier. There's a clever way of solving it. That's just all I wanted to say. Because at my place I work at, we do a bit of friendly competition between colleagues with Advent of Code. And this weekend we're trying to code golf, so we're trying to write a very small program that hopefully fits in a tweet like we saw with Thomas yesterday. But my solution didn't quite end up being tweet-sized, but it's a lot shorter. It relies on some clever tricks, but it's a lot shorter. So basically what we're doing is we're reading all the FB strings, and then we're mapping over them, and then we're just converting every F or L we see to a 0, every B or R we see to a 1. We make it a string again, and then we convert this binary string to an integer. And this is the same as we did at the end of previous session. We just create a set of all the possible or all the potential seed IDs, and we take the set difference with whatever we had, and there's one single seed ID not in the given set, and that's ours. So that was day 5 revisited. Let's go to day 6, attempt 1. Day 6, custom customs. As your flight approaches the regional airport where you'll switch to a much larger plane, custom declaration forms are distributed to the passengers. The form asks a series of 26 yes or no questions, and they're marked A through Z. We need to identify the questions for which anyone in your group answers yes. Okay, so we have a group of people answering 26 questions, and we need to find the questions where anyone says yes. So just at least one person. Okay. Programmer humor. So it's just us, cool. Person next to us is experiencing a language barrier. For each of the people in their group, you write down the questions for which they answer yes. One per line, one person per line, probably. So there are 1, 2. In this group, there are 6 questions to which anyone answered yes. So those are the different characters we find in those listed yes answers, let's call them. Several people can answer yes to the same question. For example, A, another group asks for help, and another, and eventually you've collected answers from every group on the plane. So what we have is answers for every group on the plane. Okay, each group's answer is separated by a blank line. Okay, so we have to take those groups into account maybe. And within each group, each person's answers are on a single line. So this is a group, this is a group, this is a group. Okay, makes sense. We have 5 groups, The first person answered 3 first questions with yes, second group contains 3 people, and they all answered yes to 1 question individually. Okay, this is making sense. So the sum of these counts. What are we counting? The questions on a group level. How many questions got answered? Let's take a look at this one, because that's the most interesting one. The third group, they have 2 people, A, B, A, C, They answered yes to 3 different questions. So we have to tally up the different questions every group answers yes to. And for each group we have to do that, and then we have to total it to get our puzzle and our answer. And of course it's a huge a huge list again. Let's pull in our input. I love how these examples are always like 3 lines of explanation, and then you look at the actual input and it's 2043 lines of a random gibberish. So let's think strategy here. We're gonna parse again, yes. First we have to split up into groups, yes. Then, does it matter if you split up per person? Yeah, we do have to split up per person. No, actually we don't even have to split per person just yet, I think. Just count the different letters in every group. For example, group 4 here, 1, 2, 3, 4, that should only have 1. Question A, yeah. Maybe it's dangerous to go down this route for part 2, but we'll tackle that part when we get there. So the first thing we have to do is split our input into the different groups. And I learned a couple of days ago that reading from a text file and copy pasting example with new lines is not the same, so I'm not gonna do that today. I'm just gonna work on my input directly, and if things go wrong I'll take a few steps back and work with the example. So we have to let's not split, or let's not read lines again, let's read text. So we have a single string we can parse ourselves. Yeah, and let's split that on this an empty line. Remove empty entries is actually what we want. No, but actually does that too. I don't think we'll encounter any of those. Is this... No, this is not what we want. We don't want just a new line, we want multiple new lines. So let's look at the first. Let's look at the first group and see if it's correct. It should be CJC blah blah blue. CJC, and it ends with a C, and the next one is Y blah 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 and ends with WP. Yeah, that looks correctish enough. I'm just gonna call them groups. Now we just have our groups, and for every group we have to count the number of different letters. Yep, so groups map, and every group thing here is a string. Yeah, and we just have to tally up or group the letters. Should we remove the white space now? Yeah, let's remove the white space now. I'm just gonna throw away individual person information as well just for now. I'm just gonna say remove white space and take it from there. No? Why is this complaining? Unexpected quote symbol. Is the empty character not... What's wrong? New car. Can you not do an empty character? That's something I did not know. Okay, then let's not try to remove it this way. You know what? Forget it. Let's just let's group. Let's group all the different letters, or no, all the different characters. Yeah. And then we have to just ignore the new line. This is a grouping now, right? What does this return? A sequence of key value pairs, yeah. Groups is not defined. Okay, sorry. Yeah, so it's grouping. Actually, we don't actually need the groups, we just need a distinct. So let's not count them, we don't need to count, we need to have every different value in there, sure. Interesting. What's this? 113, 110, are there like weird characters in here? What is that weird 013 thing? Is that an enter? Is that a character return and a new line? Yeah, it's coming back everywhere, so probably that's a character return new line. Okay, let's filter those out. Except, you can give except an input sequence. So let's remove new lines from display. Group of distinct characters. No, that was not a problem. Jesus, sometimes these IDs tend to be, or try to be too helpful. Okay. So now we have for every group the number of question, or every question where at least one person answered yes, and we just have to tally those up. Yeah. So let's keep going. And this should be a sequence of numbers, yeah, and let's just sum them. There we go. Good enough. Part 2. Part 2. Let me quickly move my code. There's not much code, but let's just play it safe. Part 2. As we finish the last group's declaration, you notice that you misread one word. Everyone answered yes. So yeah, now we do need to take the individual answers into account. So we'll basically have to rework part 1 as well. So now we need to check that every line has the answer before we take it into account. Let's go over the examples quickly. Yeah, there's only one person, so all persons answered to those 3. Yeah. The second group, nobody, I'm guessing. Yep. Third group, only A. Fourth group, only A. Fifth group, only B. Yep, that's okay. So now we have to count the questions where everyone answered. So going back to our code, our groups are still correct, but instead of just lumping every individual's answer together and taking the set, basically, this could have been a set thing as we did yesterday as well. But so instead of lumping them together and seeing how many questions had at least one answer, we need to find out that every individual in the group has. So let's take the thing that differs, that's this. No, actually it's group distinct except new lines, yeah. Let's take a step back, let's think about how we're gonna do this. So if we have one group in our hands, what do we do? Let's go with set logic again. If we're doing set logic, if we have one individual's answers, the other individual's answers, we just have to take the, what's it called? Intersection? Intersection. If you recursively take the intersection of every answer in a group, that's what we need, huh? Is there something like set intersect with 2 sets? Intersect many? Oh, this is starting to sound interesting. A sequence of sets. sets. This is what we need, I think. It's the intersection, not the union. Yes, it's the intersection. So a group is a string where we have to split on new lines again. Yeah, let's do it that way. So let's split on, I'm gonna extract the function quickly. Let's split s, and then just do this. Let's provide the separators as well. Is it called delimiter? Separator. Needs more type help. We can give it that. If I can type, that is. Oh dear. There we go. So all that just to do this. This should be functionally equivalent to what we just had. If we at least load split into the REPL, yeah, that looks like what we had. And now we can split our group into individual answers. So split on a single new line this time. Okay. I'm just gonna throw it away, it's not that difficult. So when we have a group, we still have a group, let's split that group into individual lines, so C, JC, CK, Q, yeah, that looks correct. And now we can just calculate the intersection. So so that's for one group. Let's just pipe. So for every individual, make the set. So instead of this works because a string is implicitly a sequence of characters. So when I do set of a sequence, it will generate a set of characters. I'm guessing. Yes, it will. Yeah, and then we have to intersect many. And then we have a single set containing the intersection for every group. Could it be that for part 1 it's only a C? Yeah, that looks correct. So we're almost there, I think. We just need to see how long every set is. And then we need to tally it up. And that's a bit shorter than the 6,000 we had, so that sounds like it could be correct, and it is correct. This was a fun and quick puzzle. I enjoyed it. It's a bit unreadable, but I'm not going to clean it up today. I'll leave that up as an exercise to you, dear watcher. I hope you enjoyed day 6 in Advent of Code, and I'll see you tomorrow.